Hi everybody, welcome back. It's time to continue our learning in our world of chemistry. Today we're going to talk about chemical properties and interactions. Do you have your green notes ready? Here we go. First, let's start with a little bit of review of some of our definitions. We've learned some really important vocabulary, so make sure you've been studying Quizlet. Let's review some of our definitions. Let's start with molecule. A molecule is when two or more atoms combine chemically to form a bond. So that means those electrons are either given or they are shared between two different atoms of two different elements, or it could be the same element too. They can be the same atom or different atoms, just like I said. So let's think about oxygen and hydrogen. Two hydrogens come together with one oxygen to make water, H2O. It is a molecule because those two atoms have combined, or in this case, the three atoms have combined chemically to form a bond. Our next vocabulary word is a new vocabulary word. I'll make sure this gets added to Quizlet. A pure substance. A pure substance is made up of only one kind of atom or molecule. So that means in that substance, every single molecule is the same molecule. For example, pure water is only H2O, just H2O. In a lot of our drinking water, you can find other things dissolved in the water, but in pure water, every single molecule is just H2O. Also, minerals like graphite and diamonds, do you know that they're all just carbon atoms? That's right, it's the same stuff. It just depends how those molecules are arranged or how those atoms are arranged. So, pure substance is only made of one kind of atom or molecule. Another important vocabulary word we've been talking about is compound. A compound is when you have two or more elements combining chemically, but they have properties different than the elements they are made of. So remember, a compound is where you have different kinds of atoms combined together to make a molecule, just like we practiced in class. So that is the definition of a compound. An example is, well, water. Water is a compound because it's made of oxygen and hydrogen. They're two different elements combined together. At room temperature, oxygen and hydrogen are gases, but when you combine them at room temperature, they make a liquid. It has a property different than the elements they are made of, and this is a compound. Next, a mixture. This is another new vocabulary word. When two or more substances combine physically but not chemically, we call that a mixture. Think about a fishbowl. Inside of a fishbowl, you have a fish, maybe you have plants, maybe you have rocks. So all those things are combined together in the same space physically, but not chemically. One's not dissolved into the other. Also, even though you see sugar water or maybe salt water, these things are also mixtures because you can actually separate the sugar and the water or the salt and the water. If we dissolved or if we got rid of the water, if we made the water evaporate, even the sugar that's dissolved in it would be left behind. You would see the sugar crystals or the salt crystals. Have you ever put a bunch of salt into water or maybe left a glass of Kool-Aid sitting out too long on the countertop? When the water evaporates, the sugar and the food coloring is left from the Kool-Aid or from whatever you were drinking. You should try it sometime. All right, so now we're going to talk about physical and chemical properties. The definition of a physical property is a property observed by using your senses. For example, the state of matter that it's in. Is it a solid, a liquid, or a gas? What color is it? The taste, the smell. These are called physical properties of a substance, something you can touch and see. However, the chemical properties of a substance describe its ability to do something. So we're talking about basically its reactivity. How combustible is it? How rustable is it? How flammable is it? Flammability, combustibility, and rustability all describe the ability of a substance to do something, to react. So let's check out something called methane that we've talked about quite a bit for your explosive clip.
All right.
With the room filled with 9% methane, will this finally yield the Hollywood blowout?
All right, here we go. Ideal gas-air mixture, born explosion in 3, 2, 1. Oh, yeah! That is awesome! We blew out the whole front.
Yeah,
We couldn't have done that if we planned.
that was perfect.
And there you have it. One magnificent, made-to-order apartment explosion.
Pretty cool, as always. Thank you, Mythbusters. Okay. Scientists confirm that a chemical reaction has happened by seeing if a new substance with new properties have formed. So we can see evidence of chemical reactions. It's not always super explosive and awesome like we just saw, but we can see if a reaction has happened by seeing if there is a new substance with new properties. We even observed this in class the other day. Remember when we went outside and did this? Yeah, that was pretty epic. So all we did was we took baking soda and vinegar, and it gave off carbon dioxide gas, and that's what made the bottles bust. What's made that explosive action. It was the pressure of the carbon dioxide being given off from the baking soda and the vinegar. This is proof that a chemical reaction has taken place, the production of a gas. Another proof that chemical reaction has taken place would be the production of light. Think about when something is burning, logs, fireworks, even glow sticks. Glow sticks is proof that a chemical reaction is happening inside of the glow sticks. Think about when you get a glow stick. You have to break it and then you shake it. So let me have someone else give you a great explanation of how glow sticks work.
Hey, it's me, Lauren. You've seen glow sticks before. They bring a festive glow to Halloween trick-or-treating and New Year's Eve celebrations, and they're useful gear for explorers from scuba divers to spelunkers. When you find a bunch of people gathered to party in the dark, at least a few of them will probably be wielding glow sticks. But what the heck are these things? How do they work? Glow sticks are powered by a process called chemiluminescence. Don't let the name scare you. Luminescence is just a fancy word for any emission of light not caused by heating. The chemiluminescence in glow sticks is a pretty simple reaction caused by mixing chemical compounds. Compounds are made up of different elements bonded together in specific proportions so that they can't be mechanically separated. It takes a chemical reaction to sort out, for example, the oxygen from the hydrogen in water. When you mix a compound with other stuff, you can set off that reaction. And as the atoms rearrange themselves, they'll either absorb or release energy. If you look inside a glow stick, you'll see that there's a small glass vial in the tube. This vial typically contains a hydrogen peroxide solution called the activator. It's floating in a solution containing a compound called phenyl oxalate ester and a fluorescent dye. When you snap a glow stick, the vial breaks, and the hydrogen peroxide reacts with the phenyl oxalate ester, creating two other compounds, phenol and peroxy acid ester. Still with me? Good. The peroxy acid stuff is unstable, so it decomposes and produces additional phenol. It also produces a cyclic peroxy compound, which decomposes to carbon dioxide. This decomposition releases energy to the dye. The electrons in the dye's atoms jump to a higher level, then fall back down, releasing energy in the form of light. The other chemicals in the fluorescent dye determine the color of this light. Now, all of this happens within moments of snapping and shaking your glow stick. Depending on which compounds are used, the chemical reaction can continue for anywhere from just a few minutes to a few hours. Warmer temperatures will accelerate this reaction, making the stick glow brighter, but for a shorter period of time. When it's cooler, the reaction will slow down, making the light dimmer. Which means that if you want to preserve your glow stick, put it in the freezer overnight. It won't stop the process, but it will slow it down and drag out the reaction. So it turns out that there's some pretty nifty science behind the humble glow stick. Check it out the next time you're scuba diving, partying, or, you know, whatever it is that you do in the dark. Thanks for watching. Is there any other party science that's always mystified you?
All right, we'll talk more about other party sciences later, but that was pretty awesome. So that's how glow sticks work. It makes a production of light because those two chemicals mix together and the energy is given off in the form of light. Other signs that a chemical reaction has taken place is a change of temperature. Think about those awesome Hot Hands hand warmers. You shake up that little bag and you put it in your hand, and all of a sudden your hand gets nice and warm. That change in temperature, that heat, is produced by the mixing of certain chemicals, and we will play with those some more in class soon. Also, something called the formation of a precipitate. Yes, a precipitate. That is a solid substance that forms from a solution of liquids. So if you mix together two liquids and all of a sudden this solid substance seems to appear out of nowhere, that is the production of a chemical reaction. It is, remember, matter cannot be created or destroyed, it can just change forms. And so as atoms are rearranging, it makes something new. Also a change of color. Rusting. So when we have iron and we have oxygen, they combine together to make iron oxide, which is just rust. So that change in color, that rust, is also a sign that a chemical reaction has happened. Make sure you write all these down on your green notes. So now we've talked a little bit about chemical reactions and how we can prove that they have happened. Thanks for watching and have a great rest of your day.